GM quietly gets into the gigacasting game after buying key Tesla supplier. General Motors acquired one of the most well-regarded sand casting specialists in the world and one of Tesla's rapid prototyping partners earlier this year, quietly entering the gigacasting game, as shown in a Reuters report published by Automotive News. Tooling Equipment International, or TE, has worked with Tesla to develop gigacasting mold prototyping for the Model Y, Model 3, Cybertruck, and Semi, all while dramatically cutting development time and costs during the process. By using casts made out of industrial sand with 3D printing, TE, along with 3 other suppliers, helped Tesla have the time it takes to develop a car from the ground up, going from 3 to 4 years to 24 months at most. GM and EVs. GM and Honda ditch plans to make cheap electric cars together. GM delays Chevrolet Equinox EV market launch. But not anymore. Since July 2023, TE has become part of GM's global manufacturing division, which oversees all of GM's automobile and parts manufacturing operations, according to a source with direct knowledge of the matter. General Motors acquired Tooling Equipment International TE to bolster its portfolio of innovations and secure access to unique casting technology, GM said in a statement. The American car manufacturer first came in contact with TEI's know-how when it approached the supplier to test and produce some underbody castings for the upcoming $340,000 Cadillac Celestiq, a source told Reuters. As luck would have it, TE won the 2023 Casting of the Year award from the American Foundry Society for those Celestiq castings. General Motors isn't the only so-called legacy automaker to go down the gigacasting path that Tesla carved. Earlier this year, Toyota announced that it too will employ the technique for its next-gen electric vehicles, which are expected to hit the road in 2026. Volvo, Ford, and Hyundai are also going down this route. Gigacasting essentially means that a car has fewer but bigger metal components, which reduces complexity and manufacturing costs. Where a current vehicle might have a front subframe assembly made out of dozens of individual parts, a next-gen vehicle might have a single-piece subframe thanks to gigacasting. Mind you, TE was not responsible for the massive die-casting machines that Tesla is using in its factories. Instead, it and others like it makes test molds out of industrial sand using digital design files and 3D printers known as binder jets. These build a sand mold that can then cast molten alloys. Compared to legacy casting techniques, this prototyping method enables a sand mold to be modified and reprinted quickly if adjustments are needed, with minimal cost. Source: reposted and summarized from Julian Nystrom at Inside EVS.